Okay, so in this lesson, we are going to continue with dealing with parallel lines and the angle pairs that are on those parallel lines. And today we're going to work backwards. We have been saying if the lines are parallel, then opposite or alternate interior angles are congruent, alternate exterior angles are congruent, corresponding angles are congruent, or same side interior angles are supplementary. And today we're going to do the converse of that. So if corresponding angles are congruent, so what we are doing is we are starting knowing that corresponding angles are congruent. So you will be given information about the angles. Therefore, if corresponding angles are congruent, then the lines are parallel. If the corresponding angles are not congruent, for instance, if they look like this, these two angles are corresponding, right? Those two angles are corresponding, but they're not congruent. Well, all that means is that those two lines are not parallel. It doesn't mean that they're not corresponding. They are. Corresponding is just a location. The relationship happens because of the congruency. Same thing, alternate interior angles. Remember that alternate interior angles kind of look like that Z. If they are congruent, then the lines are parallel. If they're not congruent, then the lines are not parallel. That would be the inverse of that. Okay. If alternate interior angles, if alternate exterior angles, remember that those look like this, right? Where they are both exterior and they're on alternating sides of the transversal. If they are congruent, then the lines are parallel. And if same side or consecutive interior, remember those look like this. If they are consecutive interior angles, if they are supplementary, or they equal 180. Then the lines are parallel. If they're not supplementary, then the lines just aren't parallel. They're still consecutive interior angles, they're just not parallel. Now, this is extremely important. Highlight this, circle it, star it, whatever you need to do to remember it, but vertical angles and linear pairs never prove that lines are parallel. The reason is because they are on the same vertex. So remember that to be vertical or to be a linear pair, all they had to have was a vertex in common. These two angles are vertical angles. They are congruent to each other, but there are no lines parallel in that picture. This angle here, right? This angle here and that blue angle right next to it, adjacent to it, they are a linear pair. They add up to 180 degrees. They're supplementary, but they do not prove that lines are parallel. The difference between corresponding, alternate interior, alternate exterior, and same side is these three had different vertices. They all had to be on different vertices. Okay? Vertical and linear pairs, they share a vertex. That is why they never prove that lines are parallel, ever. Only these four prove that lines are parallel. And only these things have to happen in order for lines to be parallel. Okay, so we're going to look at some pictures, and so this is where it's beneficial to have some extra little pictures to go with it, and we're going to highlight them and look at them and see how they match up, and then we're going to see which lines would be parallel. So we're going to start with angle 7 and angle 4. So to do this, what you want to do is you want to highlight or color in the sides of the angles. So we have the sides of angle 7, and then we have the sides of angle 4. And so then what you want to do is just extend them a little bit out, but you want to connect these, like these two connect. So you can see, if you extend these out, you can see the two lines that are parallel to each other. You can see that this line is parallel to this line. This is the transversal that connects those two parallel lines together. That's what you're looking for. And so we would say then that BE, line BE, is parallel to line CF. Now the order of those don't matter, EB or FC. It doesn't matter. You can say them in whatever order you want. Just remember you need to name a line with two capital letters or one single lowercase letter if you have it. So what if the measure of angle 9 is equal to the measure of angle 4? Well, let's look at that. Here's the measure of angle 9. And here is angle 4. So we highlight them, we trace them, and then we look to see. Extend your lines until you run out of space, and you can see that this to this is connected. That's that vertex, and so CF is your transversal, which means that CE is parallel to DF. CE is parallel to DF. Those are segments in this case, technically, so you can leave them like that. Okay, now let me get another picture, and let's look at it. Oh, this one right here. Sorry about that. I was looking to see which picture it was. Okay, so new picture so that you can see the new information. So angle 1 is supplementary to angle 6. Now, if they're supplementary, instantly the thing you should be thinking about is the one pair, which is same side. So in order for that to be true, for lines to be parallel, then they're going to have to be same side interior angles. So angle 1 is right here. Here's angle 1 and angle 6. Here's angle 6. And so if you connect those lines all together, trace them out so that you can see them, you can see that this line is parallel to that line. Now, if you look here, right, this is not actually a line. It doesn't have two names, or two letters, 2 points to name it with, but it is the extension. You can extend it. And so now you can see that EF is parallel to AB. Now you can name it AB, BC, CD, AC, anything. Just 2 points on that line is what you need to name it with. Okay? EF is perpendicular to BE. So EF is perpendicular to BE. So what we know is that this is true. EF is perpendicular to BE. And we know that EF is perpendicular to CF. So EF is perpendicular to CF. So when you look at that and you connect those two together, you can see that those two are supplementary. They are same side interior angles. And so since those are same side interior angles, we can say that BE is parallel to CF. Okay, let's look at 7 and 9. So with 7 and 9, I'm going to trace 7 and 9. Here's 7, and here's 9. Now, here's what you need to notice. Even if I extend these, there is no one line, no one road. If I extend these all the way up, there is no one road that connects them. There is no transversal. Okay, in fact, there are several transversals. Because there is not one single transversal, and because I don't have any more information than that, then what we would say is that based on this information, we have no lines parallel. We don't have corresponding angles, although it looks like it, right? But we don't have what needs to be that transversal, that EF. We don't have anything that is connecting. There's no direct connection between these two vertices like there is here. Here they were connected by AE. Here they were connected by EF. Here they were connected here. They were connected here, right? So notice we had 3 lines. We had 3 lines. We had 3 green lines, 3 blue lines, 4 red lines. Okay, one of the things that I told you in the beginning is you need to focus on those 3 lines. Okay, the transversal plus the 2 lines that the transversal cuts across. That's where you want to put your focus. Well, if you don't have that many lines, then you have too much information. And so, or if you have less than that, then you don't have enough information. So always be careful for that. Okay, then we have 3 and 5. So here's 3. We're going to highlight angle 3, the sides of angle 3. We're going to highlight the sides of angle 5. Here are the sides of angle 5. If I extend those and connect them together, okay, extend those, then I can see that I have transversal BC. That's your connection between these two vertices. Is one path from B to C, so it has transversal B to C, and this angle then are on these parallel lines. They're corresponding angles, so that means that BE is again parallel to CF. Okay, and those are all segments in this case. Okay. So pause it, see if you can do this on your own, and try it with this picture. So hopefully you've tried it now, but let's highlight them and check them and see. So we have angle A. So the measure of angle A is equal to the measure of angle 3. So I need to extend my lines out and see if they're going to connect. Well, this line connects all the way out. Okay, and so I connect A to C. I connect that angle A to that angle 3 along that transversal AC. So if that is the case, since that is the case, then that means that angle A and angle 3 are congruent. They are corresponding angles, and if corresponding angles are congruent, then the lines are parallel. Which lines? AG is parallel to EC. And again, the order you say those in doesn't matter. Okay, 3 and 4. So we've got angle 3. So we're going to highlight the sides of angle 3. It's at that vertex. We're going to highlight the sides of angle 4. What I notice is that there is a connector from those two vertices. So my transversal is EC. It is the connector between the two angles. I look at where those angles are. That angle is on the left side of the transversal. This angle is on the right side of the transversal. They are on alternating sides. They are in between the two lines that are going the same direction. I need to extend those out so we can see them a little bit better. And so they are alternate interior angles. And if alternate interior angles are congruent, then lines are parallel. Which lines? FE is parallel to CD. Now those are just options of how to name those points. You don't have to name them that way, or those lines, but that is one option. Okay, so let's get a new picture. So we've got some, and it's easier to look at. So angle 1 is equal to, or angle 1 plus angle 2 is 180. So angle 1 and angle 2 are 180. So if I trace angle 1, it goes like this, and if I trace angle 2, it goes like this. Now, here's the big thing you need to notice. While that may be true, it is true that angle 1 plus angle 2 is 180 because they do form this, this base right here does form this straight angle, those opposite rays, but they share a vertex. Since they share a vertex, you do not know anything about parallel lines. And in fact, look, I just have one line, 2 lines. I don't even have 3 lines. I don't have enough lines to be parallel. I have 2 lines that are intersecting. And so I would say based off that information, I have no parallel lines. These are a linear pair, and linear pairs never ever prove that lines are parallel. Okay, angle 3. So let's look at angle 3 and angle AGF. So here's angle 3. We're going to trace the sides of angle 3. And the sides of angle AGF. So A to G to F. So we're going to trace it. So I've got those. I've got my vertex of my angle up here at G, my vertex of my angle down here at C. Notice that there is no transversal that connects those. Since there's not a transversal, then we don't have parallel lines. And so again, we would have none. That situation does not create any parallel lines that we've got, that we can see so far. Okay, so what if I say that angle D and angle 2 are equal to 180? So the measure of angle D, here's the measure of angle D. Its vertex is right here, and the measure of angle 2. Okay, so the measure of angle 2, if I connect those, since I can all the way, that vertex connects B to D. I can see here I have 3 lines highlighted. That means that this side is parallel to this side. So we would name that then BG is parallel to DE. Okay, angle D is congruent to angle 1. Here's angle D again, so here's angle D, and here's angle 1. So again, if we go back, Okay, connect those vertices together if you can. I can. So since angle D is congruent to angle 1, so here's angle D, here's angle 1. They are corresponding angles. And since they are corresponding angles, and because they are congruent, I said they were, corresponding angles are congruent, then that means that, again, in this case, BG is parallel to DE. Okay, last two. Angle 6 plus angle 5 plus angle A equals to 180. So angle 6 and angle 5, if you look at angle 6 and angle 5, they go together to form this one big angle. So angle 6 plus angle 5 forms this one big angle. And angle A, here's the vertex for angle A, and they combine together to form these two angles together and this angle right here together. Notice that you have 3 lines that are highlighted, and since you have 3 lines, you have this one transversal that connects this vertex to that vertex. So we have one transversal and 2 lines that they connect. So those two are supplementary. So this angle together, 5 and 6, and this angle right here are supplementary. They're same side interior angles. Okay, same side interior or consecutive interior angles that are supplementary. Therefore, we can say that GF is parallel to AB. GF is parallel to AB. We just need 2 points off that line to be able to name it. And then finally, we have 3 and 7. So here is 3, and here is 7. Now what you should notice immediately is that they share that vertex. Anytime angles share a vertex, they're not going to prove that lines are parallel. And in fact, look at that picture. If you look at these two lines, there are no lines that are parallel in this picture at all. There's no way for me to connect them or extend them or anything else, but these share a vertex. Remember, the 4 that show that lines are parallel, they don't share a vertex, none of them. So we would say none, that there are no parallel lines based on that information. Okay, so highlight your sides, look to see how many you've got. You're looking for that direct road between the vertices, and they've got to be at on different, those angles have to be on different vertices in order to make that work. Okay, so now let's look at this with some math. So find the x and the y that will make MA be parallel to TH. So I have MA, I want these two to be parallel. So here are my 2 parallel, or my what I want to be, my proposed parallel lines, and this is my transversal. So if you look at that transversal, let's look at the information we have. We have this 54-degree angle, we have this 6x, and then we have this 7y. So we're looking for a relationship between the angles. Okay, and remember what we're looking for is we're looking for angles that are going to be congruent or angles that are going to be supplementary. These angles, if you look here, this angle right here and this angle formed right here, these 2 angles right here are they're corresponding angles. Okay, so corresponding angles are congruent. If corresponding angles are congruent, then the lines are parallel. Okay, then that will make that happen. If those corresponding angles are equal to each other, then those 2 lines will be parallel to each other. So we're going to make that happen. So 54 is going to equal 6x. So now you've got an equation, part equals part. Solve, divide both sides by 6, and you get that x is equal to 9. Once you know that x is equal to 9, we already knew this had to be 54 degrees. So the question is then, how big is y? Well, these pieces right here, they're marked for a reason. Those are marked that they're congruent. Now that's important because now we're going to fall back on what we know about linear pairs and vertical angles. Now just because linear pairs and vertical angles don't prove that lines are parallel, it doesn't mean that they're not useful. In fact, they're extremely useful. So now what I know is that these 3 angles together here are going to add up to equal 180. So part plus part plus part equals to the 180. So we can say then, combine our like terms, 14y plus 54 is equal to 180. So do the math. 180 minus 54 is 126. So I have 126 degrees left for those two angles. And those two angles are both 7 apiece. So there are 7 times apiece. So it'll be 14y. So we divide both sides by 14. So we would have 14y is equal to 126. Divide both sides by 14. And you get that y is equal to 9. That gives me the x and the y, so x would have to be 9 and y would have to be 9 in order for those two lines to be parallel. Okay, so we have the measure of angle 1 is 7x plus 36. Always label your pictures so that you can see the relationship that you have. Angle 2 is x squared. Find the measure of angle 1 and angle 2 so that those lines will be parallel. Those are same side interior angles or consecutive interior angles. Okay, they are same side. If they are same side, the relationship that needs to exist is that they need to be supplementary. In order for lines to be parallel, the same side interior angles have to be supplementary, or they have to add up to 180. So I'm going to be smart about the way that I write this. So x squared, well, let's say this, angle 1 plus angle 2 has to equal 180 because they have to be same side interior. So x squared plus 7x plus 36 is equal to 180. Now, here's where we run into a problem. Everybody kind of looks and like, oh, I have 3 pieces, so I should be able to factor that. Well, we need to get it set equal to 0. That's always your first step. So you have to subtract 180 from both sides. So 36 minus 180, you get 144. So x squared plus 7x minus 144 is equal to 0. Now you have several options for how you want to solve this. You can factor it. You can put it on the calculator. You can do any number of things. So whatever you want to do. So I want to find factors that multiply together to give me 144 that add together to give me 7. Okay, so if you go and you do this with factoring, then you would say, then what numbers multiply together to give me 144 that add to give me 7? Well, that's going to be 9 and 16. You have all these numbers. So these are all the factors of things that multiply together to give you 144. You can see that right there. Okay, all of those multiply together to give you 144, but you can see that the 9 and the 16 add together to give you 7. Now I need it to be a positive 7, so I'm going to use minus 9. So x minus 9 and x plus 16. Now everybody always forgets this step. At this point, what you want to do is you want to set this factor equal to 0. So you would say x minus 9 is equal to 0, and you would solve that little mini equation, add 9 to both sides, and you get x is equal to 9. And then you want to solve this little mini equation, x plus 16 is equal to 0. Subtract 16 from both sides. You get x is equal to negative 16. Now in an algebra world, that would have been fine. You would have kept both answers. But this is geometry, and we need to make sure that these angles work. Now I'm going to go back up here, and I'm going to start here. I stay away from the x squareds if at all possible. So if x is 9, then this would be 7 times 9 plus 36. So we go in, we just plug that in, substitute that in, 7 times 9 plus 36, and we get that this angle is 99. Okay, so this angle is 99, and we ask ourselves, can the angle be 99? Yes, even if it was drawn as an acute angle, it doesn't matter. 99-degree angles exist, and so we are allowed to have that. Okay, now we also need to test the negative 16. So if we test the negative 16, you would have 7 times negative 16 plus 36. So 7 times negative 16 plus 36 is negative 76. Now in geometry, we don't have negative 76-degree angles. And so it doesn't matter whether x works in algebra or not. It doesn't work in geometry. And so we're going to throw that answer out, and we're only going to keep x is equal to 9. If both of them worked, if both of them gave me positive answers, I would keep them both. Okay, but because they didn't, then I'm not going to keep them both. Now, one way to do this with graphing is you can graph, and what you would do is you would graph this equation, and what you're looking for is where does it equal to 0? So you're looking for where your y value equals to 0. So go look at your table and look at where your y value equals to 0. So right here at 9, you have a y value equals to 0. And then also up here, we can, I want to keep going up. It won't let me go up. Set my table. Go look at my table. So then right here, see there's also a y is equal to 0 and negative 16. So that gives you your two answers, okay? That actually gives you your answers, 9 and negative 16, okay? So those two give you your answers. So you're looking for, but you have to know that what you're looking for is where y is equal to 0. So that's another option, but you still have to check to make sure that they make sense. So let's look at this one. Angle 1 is 2x squared, so we'll label that so we can look at it. Angle 2 is 7x minus 3. Those angles are alternate exterior angles. In order for these two lines to be parallel, my alternate exterior angles have to be congruent. Okay? If alternate exterior angles are congruent, then the lines will be parallel. So I'm going to set those equal to each other. Congruent means that their measures are equal. So 2x squared is equal to 7x minus 3. Now in all factoring, except for completing the square, we always make sure that it is set equal to 0. So leave the 2x squared alone. I know the temptation is to move that 2x squared over there so that it's with the other two, but you always want to factor with your positives, with your x squared being positive. So we're going to subtract 7x and add 3 to both sides. That gives you 2x squared minus 7x plus 3 equals 0. Okay, so now what you want to do, and the easiest way to do this, again, you could do this on your calculator, look for where it sets it equal to 0, or you can start guessing and checking. We know that we want to reverse, we want to go back into our distribution, our FOIL. So you're looking for numbers that multiply together to give you 2. That's easy enough, 2x and x. And then we're looking for numbers that give you 3. Now, I know that my numbers that give me 3 are 1 and 3. Now I have to make a choice. Okay, so here's my choice. I can put my 1 here and my 3 here. That's my option. Now, if I do that, if I test my outer and my inner, that would give me 6x here, and that would give me 1x here. Now, if both of those were negative, that would give me the 7x that I'm looking for. So I just happened to guess right. Now, let me show you just real quick what happens if I guess wrong. So if I had guessed incorrectly and put the 3 here with the 2, I would have had x and 1, and it would have been minus and minus. Well, if you check it, that would have given me negative 2x, and that would have given me negative 3x. That adds to negative 5, not negative 7. So I would have guessed wrong. So it is simply just guess and check, right? You can guess and check once you know that you're down to those two. Now be careful here. Each factor has to be set equal to 0. So 2x minus 1 is equal to 0. Add the 1 to both sides. You get 2x is equal to 1, or x is equal to 1/2. And then x minus 3 is equal to 0. Add 3 to both sides, and you would get x is equal to 3. Again, in geometry, we always need to check and make sure that our answers work out. So if I come over here and I do 7 times 1/2 minus 3, I get 7.5 minus 3, which is 0.5. Can we have a 1/2 degree angle? Absolutely. As long as it's positive, you can have it. And then we need to test our x, so it'd be 7 times 3 minus 3. That's 21 minus 3, which is 18. And I can certainly have an 18 degree angle. Okay, so it all comes back to these relationships that we've already been talking about. If corresponding angles are congruent, if alternate interior angles are congruent, if alternate exterior angles are congruent, then the lines are parallel. And if same side or consecutive interior angles are supplementary, then the lines are parallel, and we can set up our problems accordingly. Always look for 3 lines. You're looking for the angle to have 2 different vertices and 1 line that connects between the 2 of them.